Okay, for next question, it's given that we have to calculate the work done in raising a stone of mass 6 kg. So this is the mass of the stone, which is 6 kg, and it has a specific gravity of 2, which is immersed in water. So what is specific gravity? Or specific gravity is also called relative density, and it's given by specific gravity or relative density is equal to the density of stone, the ratio of the density of stone to the density of water. So this is the density of the material divided by the density of water, which gives us a specific gravity of a certain material or substance. Okay, in this case, the specific gravity or relative density is 2. So let's write down 2 here. So this is now equal to density of stone upon density of water. And if we cross multiply this gives me that density of stone is 2 times the density of water. 2 times the density of water. So that means according to the Archimedes principle, the stone will sink. Okay. Now density of stone is 2 times the density of water, or else we can say that the density of water is half the density of stone. So this is the density of water. So now it's given that it's immersed in the water and we have to take it from a depth of 4 meter to 1 meter. That is, we have to raise the stone. Let's say this is the free surface of the water and this is the depth, that is 4 meter, and this is the depth, which is, let's say, 1 meter. So we have to raise the stone from a depth of 4 meter to a depth of 1 meter. So that is, we have to raise it to a depth of 4 minus 1 is equal to 3 meter. Now, we know that whenever an object is immersed in a liquid, its weight decreases because there is a bind force. So there is a bind force acting on this stone by the water. This is the bind force that is acting on the stone, and the weight of the stone is, so the bind force is acting vertically upwards and the weight is acting vertically downwards, the net force acting on this. So the apparent weight of this stone in the water will not be the actual weight, because the actual weight of the stone is 6 into, we know that as weight is given by m into g. So this is the actual weight, but in this water it will be less because the bind force is acting on it. So so that would be the apparent weight of the stone in the water, which should be equal to, we have to subtract the bind force from the actual weight. So this is the apparent weight, and in this case we have to find the actual weight and the bind force. Now let's find out the what is the actual weight. So the actual weight of the stone is given by the formula m into g, where m is the mass of the stone and g is the acceleration due to gravity. So let's try to convert it into mass and density. We know that density is given by mass per unit volume. So mass is equal to volume into density. So actual weight of the stone, we can write it as the volume of stone into the density of stone into G. So let's keep it as the first equation. Now let's find out the bind force. So the bind force will be equal to the volume of the water displaced by the stone, or sorry, the weight of the water displaced by the stone. So bind force is equal to the weight of water dispersed according to the Archimedes principle. Archimedes principle states that whenever an object is immersed, so the volume or the weight of the liquid displaced by its volume is equal to the bind force, and here the bind force should be equal to the weight of the water displaced by stone. And we know that the weight of the water displaced by stone should be equal to volume of stone. So weight of water displaced by stone should be equal to the volume of the stone into, because the formula for weight is m into g and mass is volume into density. So here the mass is replaced by the volume of stone and it should be the density of water. So here we will write the density of water into G. Okay, now we know that the density of water is half the density of the stone. So instead of density of water, we can write density of stone divided by 2. So because the density of water is half the density of stone. So it's the density of stone. Now volume of stone into density of stone into G. This is m into G. Volume of stone into density of stone into G is the actual weight of stone, which is m into G. So this now becomes mg by 2. So this is the bind force that is acting on the stone, and now the on the stone, and now the apparent weight of stone is equal to the actual weight minus the bind force. So this is the actual weight, this is the bind force. And if we take LCM, this is now mg by 2. Let's find out the work done. So the work done is equal to force into displacement here, because the both the force and the displacement both are in the same direction. So theta is 0. So we will just use the formula work is equal to force into displacement. And now here the force is equal to, so what should be the force applied to raise it to a height h? So force applied should be equal to the weight of the stone in the water, which is the apparent weight. So this force should be the apparent weight of the stone. So that is mg by 2. And the displacement is, we have to raise the stone from the depth of 4 meter to a depth of 1 meter. So the displacement is 3 meter. So this is 3. Let's put in the respective values. Mass of the stone is 6. G has to be 10 into 3 by 2. Okay. So this is, sorry, the mass is 6, G is 10, and displacement is 3. So this is 2 5s are 10, 6 5s are 13 to 3 is 19 G. So the work done to raise a stone of mass 6 kg immersed in water from a depth of 4 meter to 1 meter is 90 joules. Do like, share, and subscribe. Thank you for watching.